Alright, this is going to be a really quick short video about the distributive property. We're really not going to begin anything probably until Tuesday on this. We need to go over some integer operations again, but apologies for not getting this up as soon as I thought I would. Just had some things happen this weekend that were somewhat unforeseen. So real short, distributive property, keyword on this one is distribute. Okay, so I'm going to show you one of two things here. Okay, I'm going to show you what it looks like with numbers and then really talk about when we would use that. Okay, so with distributive property, you're going to see that when we have parentheses. So with numbers, just to show you an equation like 7, and it's going to be times the quantity 3 plus 4. So normally what we would do here is we would do 3 plus 4 first, but what I'm going to show you is two ways on this. We can distribute the 7 times 3, and then to that we can add the 7 times 4. So if we do this, we would have a 21 plus 28. But what that would look like normally when we use PEMDAS is we would analyze what is inside the parentheses first. So we would end up with a 7 times 7, which is 49. But let's go back down here and find the sum of 21 and 28. That would be 49. So when we just have numbers, we're going to use PEMDAS because that's a lot easier. However, when we get to algebra, that's where it gets a little bit more tricky. We will have something like this: 7 times the quantity x plus 4. We're stuck with PEMDAS because we cannot analyze what's inside of the parentheses because of the variable. So this is where we would come up with the distributive property and where it's useful. So what we're going to do is we're going to take the 7 and distribute it to the x and multiply it. 7 times x is just 7 times x. We're going to keep the addition, just bring it down, and take 7 times the 4. So we have 7 times 4, similar to what we have over here. So 7 times x is just 7x, plus 7 times 4 is 28. Now because we don't know what x happens to be, that is as far as we can go. So we shuffle that up here, and we're going to just run one more real quick equation just so you can see it, so what it looks like. We're going to throw in some negatives on here, and we're going to just use the same numbers that we have, but we're going to twist things around a little bit and show what it looks like with a negative number. Same concept though, we're going to multiply by negative 7. So we just have negative 7 times x. This minus sign is kind of an interesting one. So we're going to keep it minus. We're going to subtract negative 7 times 4, a positive 4. So when we analyze this, we have negative 7x. Can't simplify that anymore. And we're going to keep the minus sign there. And negative 7 times 4 is negative 28. So we can leave it there, but more often than not, you're going to see this rewritten as negative 7x plus 28, because subtracting a negative is equivalent to adding a positive. So I know this is quick, real short, but I'm going to have some kiddos sign off and say good night.
Good night. Good night.
Hope this is at least a good start.